Okay, so put some forces on here. Got a force going down there, force going down there, tension and ropes there, smooth pulley, so it's going to be the same. It says that it's 0.8 seconds. A goes down here. After 0.8 seconds, we've got to calculate the distance, given the acceleration. So this is just going to be, the first part, it's just going to be a constant acceleration question. A in this case is 1.4. S is what we want to find out. Know that T is 0.8 seconds, and we know it's released from rest, and we really don't care about V. So I've got to use the formula without the V in it, and that be S equals UT plus a half AT squared. So S will equal 0 plus a half of A, so it's plus 0.7 times by 0.8 squared. So S will equal 0.448 meters. So calculate the distance, and I need to calculate the speed now. So that means I'll need to work out the speed or velocity. So I'll use the one without S, so that will be V equals U plus AT. So V will equal 0 plus 1.4 times by 0.8, and that equals 1.12 meters per second. That's the first part. And then the second part, show that B rises a further 0.64 meters after striking the floor. Okay, so after A hit the floor, B is going to keep on going up. With acceleration will now change because it'll be under gravity, but it's still going to be constant. So I've got the STUVA again, and I want to work out what S is to see how much it goes up by. The initial speed is 1.12 because that was the final speed as A hit the ground. And V, it will stop when it gets to the top, and our acceleration is minus 9.8 because I'm having it going up like this. Need the formula without the T in it, and that will be V squared equals U squared plus 2AS. So 0 squared equals 1.12 squared plus 2 times A, so it's minus 419.6 minus 19.6 times by S. So S will equal 1.12 squared divided by 19.6. So S will be 0.064 meters. And calculate total length of time for which it is rising. To do that, I need to find out what the time is. So I will use, I'll take it right up to the top here now. I'm going to use V equals U plus AT. And that means that 0 equals U is 1.12. And A is minus 9.8 times by T. So T will equal 0.114287. And therefore, total time I need equals the original 0.8 plus that 0.114, which equals 0.914 seconds. And now I can go on to part 3. I've got to sketch a graph. So velocity time, velocity. And time 0, the velocity is 0, so it'll start there. And after 0.8 seconds, it has now, well, it's going 1.12. So it goes up to that point there. Constant acceleration is a straight line. That's 1.12. And then finally, at 0.914, it's back there, and that's our acceleration there. That's our minus g actually, and that's what that will look like. Now part 4. Okay, it's got some accelerations. So that's my object, like so. Forces, that's my weight of A, so I'm going to call that AG. and that would be the weight of B, so I can call that BG. And it says the tension is 5.88, so it'll be 5.88 both of these, and we know that the acceleration, there's no more forces there, acceleration down on this side is 1.4, and therefore, because it's an inextensible string, and therefore linked, it's got to be exactly 1.4 on the other side, but that side going up. So if I resolve downwards for this bit, then I'm going to get resultant force equals mass times acceleration, and so that'll give me that AG minus 5.88 equals A times G, the mass times 1.4, acceleration is 1.4, the mass I'm saying is A, take out A, so that means that A G minus 1.4 equals 5.88, so A equals 5.88 over 8.4, which equals 0.7 kilograms. And then I have to do the same thing with this side here for B, and for this one I'm going to resolve upwards in the direction of the acceleration and give me resultant force equals mass times acceleration, and going upwards I've got 5.88 minus BG, and that will equal B, the mass of B, which I'm going to B, times acceleration 1.4, and add that will give me 5.88 equals 11.2 B, so B equals 0.525 kilograms. So those are two things there. And finally, part 5, I'm going to do up here. I'll go somewhere. Part 5, pulley has a mass of 0.5 kilograms, and so that's 0.5. It's got the ropes down here, and it's supported by a chain up there, and I have to work out the tension in this chain. So I have to work out tension in that. This has got a mass of 0.5, so that'll be 0.5 G. Before it strikes the floor, which has worked out that it's got 5.8 going up there, so it's also 5.8 going down on both sides, and so therefore the tension, change colour, the tension will equal the 0.5 G plus, that's tension going up there, plus 2 times by 5.88, so that will equal 16.66 newtons is what the tension is for the first part. That's A, and then for B, immediately after A strikes the floor, then there'll be no tension. Well, there's no tension in the string something here, obviously tension in a chain, so T will equal 0.5 G, so T will equal 4.9 newtons, and that will be the end of question 7 and the whole paper.